My name is Greg Marcoux. Again, I'm one of the assistant directors of admissions. I'm sure many of you have already seen my face in one of these webinars. I want to thank you all for coming to our material science overview webinar. We have Ramy, who's one of our professors in the department, and then we have one of our student speakers as well. They'll get started in just a few minutes. We are having a little bit of technical difficulties with Ramy's feed, so he's working on refreshing his screen right now. Hopefully that'll help out. But again, I do want to go over the chat feature before we officially get started here. It is a moderated chat, so when you submit something in the moderated chat, I will see it first. So for example, I just saw Katie's message at 2 minutes and 34 seconds, and then I will send it through now. So I will see all chats beforehand. I will answer one question at a time just to keep it from getting a little confusing. If you have any questions, submit them through chat, and then I'll answer them via the chat feature, or if they're more material science engineering or engineering specific, I will forward them at the end for our student and our professor to answer them there. So if you've submitted a question, don't worry, I have it, and I promise we will get to it. And now that Ramy's back, I will say goodbye for now, and I'll leave it off to them.
Perfect. Thank you very much, Greg. Katie, you are our only customer, it seems like. Lamarca, do you hear me? Cataldo. All right. I assume Katie does too. Yes, she did. Let's see. Let me see if I can communicate with Katie. Yes, she can hear me. Perfect. Do you see the slides, Katie?
So that's different. That just turns it off. I would have to stop my video and audio altogether, I believe.
Do you see like an unmute? Can you unmute yourself if you need to talk? Because I think the chat is coming. I'm not sure if it is possible for the participants to speak.
No, the students are not, participants aren't allowed to communicate.
Speak?
Yeah, it'll just be you. They'll be able to communicate via chat.
So this is an interesting form of democracy.
Yeah, exactly. Just
they can participate, but not really participate.
Yeah. So if you have any questions, they'll come in through the chat, and I'll keep the material science ones for the end so that you guys can answer those, and then I'll answer any admissions ones while you guys are presenting.
And how long? I didn't ask this to you, Greg, before. How long do you want us to do this?
As long as you want.
I mean, I will stay here as long as somebody's asking the questions.
Yeah, exactly. That's my stance too. I got nothing after this.
Okay. Katie, I'm just waiting to see if anybody else will join. So
yeah,
I'll give you another 2 minutes.
We have 18 participants now. Katie's the only one that said anything via chat.
Oh, are they all logged in?
They are. Yep. We have 18 participants. Yeah. So there's a bunch
For
of
some reason, I assumed because only Katie is active on the chat, I assumed only Katie is joined. No, very good. Yeah, I'm ready to go then. That's
perfect.
Fine.
Yeah, we got 18 people here. So yeah, everyone have a good webinar. Again, I'll be here for any admissions questions.
All right. Perfect. Thank you. All right. Well, thank you very much. I am Professor Rahmi Özışık in the Materials Science and Engineering Department, Rensselaer Polytechnic Institute. I have Cataldo Lamarca, Kai. We call him Kai, right? I don't, but your friends do. Kai is an undergraduate in our department. He is also the president of our undergraduate student organization, Material Advantage. And Kai, you can join in, hop out anytime you want. What I would like to do today is to take this opportunity to tell you some things about RPI, and maybe more specifically about Material Science and Engineering Department. Ed Palermo, who was going to host this webinar initially, unfortunately is not available, just a last-minute issue.
So wait, they can
but
only
everything is okay.
The one slide that we're
All right,
presenting.
let's
I'm assuming
go to our
larger
next slide. I hope everybody is seeing a map on the left and 2 pictures on the right. Yeah. So RPI is located in Troy, New York. We are very close to Albany, New York, which is the capital of New York State. There are 3 big cities in this vicinity. Schenectady, Troy, and Albany, Albany being the biggest. This region is called the Capital Region in New York State. We are 220 miles to Montreal, 150 miles to New York City, and I believe 180 miles to Boston. So we are right around between the three of those big cities. We do have an airport in Albany. It is one of those small airports which is very easy to get in and very easy to get out. Okay. All right. RPI was founded in 1824.
So, under settings, there's
and
a
it is
upload slides.
The oldest technological university in United States. It actually is the first university that offered an engineering degree in the English-speaking world. We have had some good reviews in the past, actually the near past. You might see some snippets from Princeton Review. There are 7 departments in the School of Engineering. We have 5 schools,
it's
by
all
the way.
Research.
School of Engineering, Humanities and Social Sciences, Architecture, School of Science, and which one am I missing?
It's very little department and a lot of research.
Well, actually, Management, Business School. Yes, 5 of those. Within the School of Engineering, there are 7 departments. However, sometimes one department actually might offer multiple majors. For example, mechanical engineering, nuclear engineering, and aeronautical engineering. These are 3 different majors, but they all are under the umbrella of one department, which is called mechanical, aeronautical, and nuclear engineering. Material Science and Engineering offers 1 undergraduate degree. It's the Material Science and Engineering degree. And that will be the Bachelor of Science degree that you will receive at the end of your 4 years, or less, right? Some students certainly finish less or quicker than 4 years. All right, we have about 140 faculty in the School of Engineering, and School of Engineering is the biggest school at RPI. RPI is known for its engineering education, but we are also a very active research institute. We are one of the top research institutes in the nation. All right, so there's a question. Let's go on. Let's go answer that. Katie is asking, I'm currently down as a biomedical engineering major. I would like to focus more in material science. Is there a way to combine those, or should I just switch majors?
I think we offer a
you can. Yes, right. There are multiple ways of combining those 2. You can do a dual major, which is you take all the required courses in materials science and engineering, all the required courses in biomedical engineering, and there are a lot of overlapping courses. For example, every department in School of Engineering requires 5 humanities and social sciences courses. Therefore, you don't have to take 10 if you are doing a dual major. You just take 5, and those 5 will apply to biomedical engineering degree and to material science and engineering degree. There are 3 elective courses. They will apply to both, and so forth. So that's and you will receive 1 diploma with both degrees listed in that diploma if you do a dual major. You can do a minor. You might be a biomedical engineering student. You can do a minor in material science and engineering, and minor in material science and engineering requires 16 credits, I believe. There is 1 required course, Engineering 1600, excuse me, which is a introductory freshman year material science course. And then on top of that, you need to take basically 4 other courses. And there are no requirements for those courses. You can pick and choose any 4 courses you want. And certainly you can take more than 4. And that's what I think. Cataldo, do you know anything else?
Specifically with the biomedical major, under BMEs, they have to pick a concentration, or at least my year they had to. And one of the 3 concentrations they were offered was biomaterials. I also believe that we offer, from the material side going to biomedical, we offer some biological courses. There's polymers, and I think Palermo right now is actually teaching his biological materials course.
Yes. What Cataldo is, there is something unique about biomedical engineering degree. At the end, you get 1 diploma from biomedical engineering department. However, you choose a specialization, and there are 3 specializations. One of them is the materials track. One is more mechanical engineering type track, and another one is, I think, imaging and something like that. I don't remember the full name of that one.
It's like MRI.
Okay.
Stuff like that.
Yeah. And insider information, I think Cataldo, and we can share insider information with you. Biomedical engineering is quite big at RPI. There are too many undergraduate students, and they do not want any more. So actually, your chances of coming to RPI is greater if you declare yourself as a material science and engineering major.
They've already been accepted.
Yes, but they can tell their friends, right? Just because you are accepted doesn't mean that this information is useful for others. Okay. You can share this information with your friends who might be considering coming to RPI. All right. With that, I'm going to move on to another slide. And what Katie is doing perfect. If I miss it, hopefully Cataldo will catch the questions in the chat, and we will answer your questions as you are asking.
Okay.
So here's the pictures of all the faculty members we have. And we have actually more faculty members than these. These faculty members here are the core faculty in material science and engineering. We do have adjunct faculty. So these are tenure track or tenured professors. We have faculty members who are not tenured. And then we have technical staff. We have 1, 2, 3 technicians who take care of our labs, undergraduate testing labs, some of the research labs, and of course we have secretarial staff in addition. Zach is asking, is the linear accelerator available for undergraduate use? I have no idea.
Who's in charge of that?
The short name for this is LINAC, right?
I think so.
I believe that's what it is.
But undergraduates can usually end up on any piece of equipment as long as they're with a grad student and have gone through training with usually.
Yes, a lot of our undergraduates do research. In Cataldo, you did research with Ramana.
Still doing research right now.
Excuse me. I've been in class for 4 hours before this, so I'm very much losing my voice today. So if you are doing research, especially with a faculty member, you will get trained, and then yes, you might have access to the linear accelerator. All right, I don't have anything. This picture is, this slide is kind of meaningless to me. There's no point in for you to see the faces of our faculty members. Maybe you might be more interested in about what's going on. There's a lot of our faculty are still research active, meaning they do research. They have externally funded research grants. They have graduate students, and they do have, in many cases, they do hire undergraduates. I, for example, have too many undergraduate students working with me. I have a hard time saying no to them, and therefore, I don't know, 9, 10 sometimes. So there are many different topics. Excuse me? Oh, yeah, there are many different topics I believe there is a slide. Let me find that one out. There is a slide of research interests of different faculty members. Nanostructured materials or polymeric nanocomposites, materials at the biology interface, energetic materials, materials for electronics applications, glasses and amorphous materials, metallurgy, and materials or computational techniques for materials research. So these are all different topics, and these are obviously just higher level names for different topics. There are many, many interesting research projects underneath these. For example, here is some actual research pictures taken from nano materials, from the study of nanomaterials. Here is one example from at Palermo, who is studying, who is mostly on the biology, materials, science interface, looking into the application of materials to biomedical systems, for example, or for biological reasons. He's interested in one current research that he has that I know of is they design these polymeric materials where the polymer would degrade under certain conditions, and degrade is completely degrade all the way to down to its initial starting chemicals. So, and generally we know that polymers are hard to degrade in nature. They take, you must have heard that the ocean has islands of plastics swimming around. So this is one method that is trying to make this a very fast process that we can use to get rid of these polymers. Let's see. There are many research going on in the glass area. Actually, Corning Glass is one of our main research partners. The research center for Corning is in New York State. It's approximately, I think, 2 hours away from us. And we do have specific funding for graduate students, like, for example, PhD students to do research, but also some money for undergraduates to be able to do their own research. Many of our students, actually, after they get their PhD, work for Corning Research, and they are responsible for creating all the glasses that you use in your smartphones. Here are some examples from metallurgy. Obviously, metallurgy is really about phase separation. How are the different phases coexist? What is the shape? What is the strength of one phase with respect to another one? So these pictures are the coloring scheme, for example, in these pictures are about identifying different phases, different grains, what is in those grains, and how does that affect the properties, the overall properties of the material. The bottom right is from one of my old research. This was a nanoporous. This is not a well, actually, sorry, this is the nanoporous metal. I do have the counterpart for a nanoporous polymeric system. These look pretty much like polymers, even though this one is, these pictures are not for polymers. All right, so we have many examples here. I don't know how much you're interested in research. As a general suggestion, I would say, and this is also my experience, first-year students, I wouldn't recommend first-year students to maybe seek research. First year would be a good year to get used to RPI, get used to being away from your families, establish friendships, establish a schedule, take charge of your own life, right? Schedule your study hours, schedule your entertainment hours, whatever. So take charge of your own life. Those things probably are good to to establish the first year, and then also in the first year, 50% of all engineering students approximately take the Introductory Material Science and Engineering course. It's a 4-credit course with a lab segment. Excuse me. And once you take that course, then you at least have some idea about materials, some of the tests or techniques that we use, and then it becomes easier to train you, let's say, to use certain equipment. Because at least you have an idea what is that equipment for. You might not understand necessarily every detail, but you are ready to being trained and ready to start using some things, do some experiments. So what I would like to do, I don't know if you have any other questions about research. Most of these initial slides were, I would say, more appropriate for graduate students, but I know many of our undergraduates are involved in undergraduate research. So maybe there is value for us to show you the research that's going on in our department. More importantly, I would think you might be interested in what is our curriculum. What do materials engineers do? What is it that we are trying to teach you? And what kind of jobs maybe are waiting for you? Let me show you a slide that I skipped over before. So this is just a slide thrown together, but this gives you an idea. All of these companies actually are where our undergraduates either interned, but most probably there are actually students working at these locations. And this really only lists some of the big companies. The only one here I am assuming that nobody might have heard is Ecovative. Ecovative is a local company originated at RPI. They use a mushroom to actually, they use a mushroom as a material. And all the other companies I'm pretty sure you have heard of here. And there are many, many more in this list than I can think of, to be honest. But what our students do at the end of the day is become part of basically an engineering team. Right? Most of these companies, it is really not possible, I don't think, anymore for a single person, a single engineer to do some task. You will probably be part of an engineering team working on a project, and the engineering team will consist of whatever the project requires, right? Electrical engineers, mechanical engineers, biomedical engineers, and so forth. And the materials engineer's role would be to choose materials, to decide maybe how they should be processed, to test the effect of processing conditions on the final properties of the material, to test the properties of the final material in general, to see, for example, if it would withstand certain loads and how long it will last, and so forth. So those would be the job of the materials engineer: testing, choosing materials, assisting other people in choosing their materials. For example, a mechanical engineer might have an idea for a design. They might make a CAD model, a computer model of this piece of equipment or tool, let's say, and they might do finite element analysis to test, right? All of these are simulations. But at the end of the day, somebody has to manufacture that product and then actually test and see and compare the simulation results, the finite element simulation results, to actual experimental data in the lab. And so those kind of things would be the job of the materials engineer. Our student population is approximately, our undergraduate student population is approximately, ranges between 20 to 30 per year. Cataldo, what is the class size for your year? Do you know?
Last I checked, we were exactly
okay. All right.
30, I think.
So 30, I would say, yeah, 30, I think is a large. You don't have to close your video. Most of these slides coming up are actually have big text. 30 is on the high end. I would say in the last 10 years, we were more like averaging around 24, 25. We are one of the smaller departments within the School of Engineering at RPI, but that actually provides us a lot of interesting advantages. First of all, if our students do want to get involved in research, then there are a lot of opportunities to do research. Because our student population is low, we can offer research to everyone who wants. And by the way, research is not mandatory. We keep talking about research, but there is no mandatory research in the curriculum. You get to know your professors pretty well. We have an interesting, our department and faculty members are all in one building, and we have a lounge on the first floor of this building, actually, which is the lounge for our Material Advantage organization, which Cataldo is the president, and I am the faculty advisor. And so students do commonly meet at the lounge, they eat, they do homework, they study together, and I like it. I wish I was a student at RPI for this reason, to be honest. When I was an undergraduate student, we didn't have a place like that. I don't know what we did, but it's a good place. Now, compared, let's say, mechanical engineering, chemical engineering, biomedical engineering, electrical engineering, these are very big disciplines. They have over 100 students per year, per class. And yes, some of them have more faculty members to be able to teach the courses that are required, that are necessary for their undergraduate curriculum, but some are not. For example, biomedical engineering actually might have less or similar number of professors as we do, and probably 4 times the number of students that we do. So there are advantages for being in a smaller discipline. We are not really, as faculty members, we don't worry about the class size anyways. So that's not an issue for us. Cataldo, any comments about class size?
Definitely for our department, specifically the faculty to student ratio is probably
I think so. Another advantage I would say of having a small student population is there are only 60 something material science and engineering departments in the whole United States. So the number of materials engineers that are graduating per given year is not that high. And I have been at RPI since 2002. And even during the 2008 crash, many, and I personally knew mechanical and biomedical engineers, and I don't need to disparage them. Katie, I'm not bringing up biomedical engineering because you said so, but it just happens to be this way. I actually knew students who could not find jobs for maybe a few years, unfortunately. That year, I remember very clearly, that year I think we had 24 students graduating. 22 of them were either going to graduate school or had jobs already. Actually, 23 of them were in this situation. One of those 23, the job offer got withdrawn. So he ended up not having a job when he was graduating. And I know he was still in the area, so it took him around 3 months or so to get a job. So 23 out of 24 of our students, nothing changed for them. The one student who did not have a job when she was graduating was actually a foreign student. And so if I remember correctly, she was waiting on her this proper visa applications, and she did within the next maybe I think 4 months or so, she did get a job with a government lab actually. So I would say we weren't affected by the downturn. So that's another advantage of being in a small department. With that, let me show you a few things about the curriculum. So what is it that we are trying to do? Most of this curriculum is common for all engineering students. So all engineering students will take some math and science courses, some basic core engineering courses. As I told you, 5 humanities and social science courses. Actually 6, because 5 humanities and science courses, and then 1 professional development 2, which happens to be a humanities and social science course. And then there are 3 spots for free electives. Most courses at RPI are 4 credits, 3 or 4 credits, but most of them are 4 credits. And therefore, 12 credits of free electives corresponds to really 3 courses. And then you see in there, material science and engineering core courses is 39 credits. I believe that corresponds to 9 or 10 courses. One of those courses being a 1 credit course.
Right.
Yeah,
Yeah,
exactly. And I'm gonna.
Yeah, that 1 credit course is taken. That 1 credit's taken first semester of freshman year.
Oh no, not that one. So then maybe we should say 2, because that.
Oh.
So the first year. So
the lab course.
I believe I have a slide for this. All right. So this introduction to materials engineering, the 1 credit introduction to materials engineering, is what Cataldo is talking about. But that course actually counts towards core engineering and not core material science and engineering. In core engineering, in this engineering, that out of 25 credits, you need 2 1 credit courses. One of them must be an AutoCAD course, a CAD and graphics, engineering graphics course. The other 1 credit could be, there are many different 1 credit courses. It could be any one of those. So Introduction to Material Science counts as one of those 1 credit courses. So here is the standard. But let me tell you something about this math and science. All of our engineering students take excuse me, 3 math courses: Calculus 1, Calculus 2, and Introduction to Differential Equations. You must take these 3 courses. Then you take 2 physics courses, Physics 1 and Physics 2. You must take 1 chemistry course, which is generally Chemistry 1. So that makes 6 courses in the mathematics and science portion. And those are the ones that are being counted here as within the 29 credits. So for example, you'll see the first semester, a lot of things can be changed at RPI. You don't have to obey. Generally speaking, you don't have to worry about which courses you are taking, with the exception of if you don't have, let's say, an AP credit for Calculus 1. So if you don't have any Calculus 1 credits, you must take Calculus 1 the first semester. A lot of courses obviously depend or have prerequisites, and Calculus 1 seems to be one of those very interesting courses that a lot of courses require. So you cannot really proceed much without taking Calculus 1. So as long as you take Calculus 1 the first semester, everything else is really flexible, I would say. But
we have a question.
yes, what CAD software do engineering students learn? What do they learn, Cataldo?
I can answer that one. We learned it's Siemens NX11. When I was taking it, I really hated it because I felt it was very useless. And then my friends got internships. One had an internship at NASA, and they use Siemens NX11 because apparently the blends and everything it does are extremely precise. And it works very well for modeling programs. So it's a good program. And I think it's also very good for finite element analysis that mechanical engineers do as well. So it's most CAD softwares, once you get past the interface, they're all the
I
same.
know that many of my, not necessarily material students, but mechanical engineering students and so forth, they talk about SolidWorks. So that is another one that maybe they learn in another course.
I think, yeah. I know civil engineers take a different course for that. I think Arrows might, but I don't think so. I know Solidworks also pops up later in some mechanical and other programs, but I think you get licenses to both.
I believe
as
so,
an
yes.
RPI student.
All right, so the first year is mostly, as you see, math and physics courses and chemistry courses, but there are 2 humanities and social science electives. As I said, you need to take 5 humanities and social science courses, and there are some restrictions to how those 5 must be taken. And there are 2 materials courses. The 1 credit course, I was told, I never taught this course, but I was told by students. Did you take this course, Cataldo? Introduction to Materials Engineering, the 1 credit course?
I did take that. I took that first semester, freshman year. Kablinski taught it. It was
all right, so not much to do. It's more like a seminar. Is that it?
Yeah, you show up once a week. It was like Friday mornings. The most exciting part was we got a tour of all of the labs in the MRC. Like we used the SEM, we looked at all kinds of other fun stuff, and we had like I think a 1 paper and 1 group project.
I'm just looking at the.
So that's the first class where you'll meet all the other materials engineers in your year, and getting to know them early is helpful because you'll be seeing them a lot.
All right, so there was a question about calculus being calculus AB in high school and a whole year course in high school, and if it would replace calculus 1. And Greg, who did the introductions, is telling that there is a whole list of AP tests and how they transfer, or which courses they transfer at RPI on the admissions website. But I'm so yeah.
Off the top of my head, I think AB counts for Calc 1 and Calc 2, but that might have changed. But there's a whole list of how they transfer.
If you're interested in material science and engineering, I would recommend the 2nd course in the spring semester, Material Science for Engineers. That's the 4 credit course, and I believe the name of this course is not this anymore. It's simply Material Science.
Yes. You want to get that one done early because that is
yes. This course should be taken the first year. Courses. You don't need to wait. You don't really need anything. It builds on your high school knowledge, and then it turns out we are simply in this course. We are touching on every subject that you are going to end up doing in all the required materials science and engineering core courses. So this is really giving you a flavor of materials science and engineering. If you are a materials science and engineering major, you must take this course anyways. If you are a biomedical engineer, declared biomedical engineer or mechanical engineer, you probably will end up taking this course also. For other engineers, this is an optional course. You don't have to take it. But if you have any inclination, if you are an undeclared major, if you have any inclination towards material science, this course will count towards your core engineering requirements. It is one of the courses that will count towards your core engineering requirements. Therefore, taking it will not create extra load on your curriculum for you. And if you like this course, that means you are probably going to like material science and engineering. If you hate this course, then probably somewhere else, some other major is your home. Kate is asking, now that IB exams are canceled, is there any change on how those credits will transfer? This is really a question for Greg. And yeah, and he's saying that at this time we have not discussed the change in the IB policy. So, all right, I'll continue with material science engineering curriculum. So here's the 2nd year. We are really going into now core engineering. So this thermal and fluids engineering 1 is one of the core engineering courses. The science elective here could be any course offered by the School of Science. It could be a chemistry course. It could be another physics course. It could be a computer science course. It could be a biology course. I mean, it's really up to you. As long as it's offered by School of Science, you can take it. A bunch of other core engineering courses, and then your first real materials core course is Structure of Engineering Materials. That is, actually this course is offered both semesters to sophomores, but generally the first semester one is more targeted towards biomedical engineers, and the second semester one is maybe more targeted toward materials.
I know in my catalog it recommended I take it.
But maybe this is the old version too. Okay.
Yeah,
so it doesn't matter. You should take this course, Structure of Engineering Materials, the second year, and you should not delay it. Take it the second year. Whether it's fall or spring is not that important. If you do have a lot of AP credits, you will have to take this course early anyways. So if you have credits for calc and one physics, both calcs, for example, one physics or chemistry or something, you might end up taking this course the spring semester of your freshman year. And this is common. I've had a lot of students who did that in the past. If you don't take this course, you'll have hard time taking any other materials course. That's why you should take this course in the second year. You don't need to wait any longer.
I think it's actually
basically, yes, exactly. So you can't come through the door in materials department unless you take this course. The third year, we are getting more into material specific courses. This thermodynamics of materials is a course that I teach. Yes, the order is wrong here because now we have a summer art semester. So if you decide to come to RPI, at the end of your second year, you will actually stay at RPI during the summer, and you will take this mechanical properties of materials during the summer. Another course called materials laboratory skills in materials, I think. It's a 1 credit course.
That's a very valuable course.
And we have this modeling and analysis of uncertainty, which is a core engineering course that is offered during the summer with a little bit emphasis. There's one section of it that is offered to materials students with a little bit emphasis to materials problems. But you can really take any section. There is no restriction. So it really doesn't matter. All right, electrical and optical properties, the kinetics of material systems, and material selection. These are all materials courses. And yes, the order is not right here. But the order is not right even in the current semester because we had to make changes to our summer due to COVID-19, obviously, because we are not going to have a face-to-face classroom teaching. No labs. So we actually took the courses that were in the summer that had lab components and replaced them with courses that have no actual lab, no hands-on lab component. So it really doesn't matter where these are listed. It's just basically going through the courses that you have to take for materials. Then fourth year, the one important course for the materials point of view is the this design and applications of materials. It's not called that anymore. It's called Capstone Experience for engineers, I think. But that's your that's a team course, and there are courses like this also where you work in teams with different majors. This one has specific projects. Maybe each team is made up of 8, 7, 8, 9 students, undergraduate students from different disciplines: mechanical engineers, industrial engineers, electrical and computer systems engineers, sometimes biomedical engineers, materials engineers. We collaborate. These departments do collaborate, and therefore projects might have students from these different majors, depending on what the project is, of course. There are many industry-supported projects for this capstone course, and there are some internal projects. For example, this semester I proposed a project which was online control of polymer extrusion. So there's a group, there's a team of students, electrical, mechanical, and materials engineering students who are working on this project together. And that's basically it. So what we are teaching in materials is very simple. We teach you starting from the atomistic structure, amorphous versus crystalline materials. How does crystalline structure affect properties? How does amorphous structure affect properties? What do processing do to structure? Because when you process something, let's assume most probably you are going to heat it, soften it, melt it, soften it, whatever, shape it, right? And then cool it down. But during this process, the structure will change. The structure, maybe the crystalline structure will change. Or if this is a metal alloy, the grain structure might change. And all of those changes will change the properties of the material. So this is what we are teaching you. What affects structure? How does processing affect structure? And thereby, how does the properties get affected by the structure and processing? This is what you are learning within the 4 years of education at RPI, in addition to, of course, other things. There are some courses here designed for leadership development, whatever, expanding your horizons in terms of humanities and social sciences, and so forth. Do we have any questions? No. All right. In our curriculum, we have 2 spots for materials electives. So here's a short list. This is not necessarily the complete list of all materials electives offered. There's an introduction to glass science, introduction to polymers, a corrosion course, thin films course, materials for energy applications, processing of biomaterials. Actually, this is now changed to materials in biology or biology in materials that at Palermo's course. And there are a few other ones actually that you can choose from. Not all of them are offered every semester, so you see some of them are marked as fall only or spring only. So you have to a little bit pay attention. And you can take materials electives even starting with the 3rd year. So they don't have to be taken at the senior year. In this schedule, they are shown in the senior year, but you can take them earlier too. There are a few. There is one restricted elective category. I think that's mostly we are asking our students to take care of it during the summer following your sophomore year. And we recommend strength of materials because that will help you in mechanical properties of materials, but you don't have to. You can choose any one of these 4, and I believe there is another 5th course here, unless that's been canceled by the School of Engineering. But
I think they actually count the BME course biomaterials for that as well. Let me look up.
Yeah.
So
open. You choose from a list, but it's not an exhaustive list. This list is pretty much correct, but I believe there are 4 choices instead of 4. 5 choices, excuse me, instead of 4 that are shown here.
Yeah, those are interesting courses. Those are very core courses.
Yes.
I took dynamic.
We have to satisfy, every university has to satisfy certain state higher education criteria. So we have to offer a certain number of engineering credits. You have to offer a certain number of math and science credits. And core, whatever your major is, certain number of courses in your own major, and so forth. So this, and some of those courses you can tell students you must take this course. But there are also rules that says students must take this many named courses, but they should have some flexibility in taking this many courses. And that's why we have a restricted elective. So you have a choice. It's a limited choice, but you have a choice that you can choose from. All right, here is some information about advanced placement. I would say take the credits. So if you have Calculus 1 credits, for example, I would recommend take it. And take Calculus 2 when you come to RPI. And this has happened. This is a true story, and it happened multiple times. A student comes in with Calculus 1 credits, takes Calculus 2, does poorly. I don't remember the exact example, but maybe the student got a C or D in Calculus 2, panicked, went back and took Calculus 1 again. There is no need for this. Retaking Calculus 1 is not going to help you improve your grade in Calculus 2. Okay? The culprit is more probably not about you not taking Calc 1 at RPI. The culprit is probably you didn't go to courses. You didn't do the homework. You didn't study hard enough.
There's plenty of tutoring available, especially in the early math courses.
Yes. So my suggestion is, I agree with Cataldo. If you have AP credits, take them. That will lower your load, and you can even graduate early. RPI is a very expensive school, so that might actually help you. There are some facts here which I don't think we need to bother with, but these are the slides that I have.
If you
you
have to choose between taking a credit for like a core course like physics or calc, or like a humanities course like AP US history or AP lit or something like that, I would say take the calc, the physics, the chemistry, and get those out of the way. They lead to a bunch of prerequisites. So you could take the humanities course whenever you want in your schedule, but you need to finish courses in a specific order for the math and science side of stuff.
I know that there is now a limit as to how many AP plus transfer credits you can have. This was more generous in the past.
Yeah, you only have to transfer.
And if Greg is still with us, he might be able to answer this. But maybe this is limited to, let's say, 32 credits. And
I think 32 was what it was before.
Okay, so I think it's still 32 then. But nevertheless, 32 is a lot of credits. So I did have, by the way, freshmen coming in with 32, either transfer and AP credits. This has happened in the past. But most students, I would say, come with maybe 8 to 16 AP. And by the way, there is no, if you don't have an AP, you don't need to worry about it. I mean, I'm not trying to scare you. So many students just come in. They don't have any credits to transfer. With that, this is the curriculum part. We can talk about a little bit social life. Cataldo, why don't you talk about Material Advantage Organization?
Sure. Material Advantage is the professional society for materials engineers on campus. I think we have 2 or 3 main focuses. One of which is social events within the department. We host a barbecue. We try to host a barbecue, but it rains every year with the department. We have ice cream socials. We have game nights. We have professional development experiences. We usually have like a resume critique. We try to have speakers come in. And we've also been running a series of chats with professors where they come tell us their life story, where they went to school, like stuff they struggled with when they were students and stuff like that. And then we also do outreach events where we go to local schools around the area and we teach middle schoolers, elementary schoolers science, what material science is and stuff like that. We're a relatively small club right now, but once you start RPI, one of the first things you'll do is they have a activities fair. I think it's actually during your NRB, your orientation right at the beginning before classes start, or that first week of class. They take the gym, they take the armory, they open it up, and every club at the school has a table. You go and you can sign up for every mailing list you want. I just filled out the form registering for that this year. So if anyone wants to stop by at our table in the fall, that'd be nice. We could talk to you, give you more information. But I think that's
what
enough
about
about
the going to the scientific conference?
Oh yeah. We also try to go to one conference every year. This past I think February, we sent 3 students to TMS in San Diego, and that was pretty fun. They watched. I know one of them presented research. They were able to see professors and graduate students present their own research in the seminar setting. It's a very valuable professional development experience because you see what people are out in the world doing. You actually watch some pretty interesting.
And the students didn't have to pay anything. Yes.
They didn't have to pay. They didn't have to pay for food, if I remember correctly. We ended up
Everything. I believe we covered everything. Accommodation, travel, food, everything. Yeah. In the past, maybe
and
when it is closer, the conference is closer, more students do go. And so
yes.
3 is, I think, on the lower side, but this was in San Diego. So
I think the year before we sent, I think, 7 or 8 to Columbus, Ohio, and we were able to drive there, which made it a little cheaper and easier to send people.
And maybe more fun. I don't know. Did you go then, Katal?
I was there. That was fun. Okay. There was one whole room they had that was just disasters in transportation material science. So like how wheels fail, how how locomotives, their axles crack and they derail. So it's like really interesting stuff. But we have a question from Katie. Do projects face real life problems that are applicable to their classes?
That depends on real life problems.
Yeah.
The definition of real life problems.
Yeah, that's
everything we do is about real life problems. However, we might not pose it like that. Every question I ask in thermodynamics, for example, is a real life problem.
If you get far enough, yeah. As an engineering student, you really have 2 main courses, which are design courses where you do work on a project with a group. In usually your sophomore or junior year, you do Introduction to Engineering Design. That's a multidisciplinary course where you're put with a group of different majored people. I was in a group with, I think, 2 mechanical engineers and 2 computer systems engineers. And they teach you the engineering design process. You prototype, you design, you test, and then you design a prototype that's a novel idea, and then you test it, and you have a demo day, and then your thing fails catastrophically in front of everyone, and then it works great. As for example, what my team ended up designing was a cat feeder that would automatically feed your cat less food if it weighed too much.
That's interesting.
So it would weigh the cat and give out enough food depending on how much your cat weighed. And that went like okay. And then also you have Capstone, which happens either first or second semester senior year, and that's also multidisciplinary.
Yes, and Katie, maybe in courses, I'm pretty sure I understand your definition of real life problems, and this might be limited, let's say, in courses, but maybe more appropriate for research topics. Even then, it is limited because, for example, as a professor, I get a research grant on a specific topic that I propose. And that might be a grand challenge issue, but some scientific topic that obviously has some relevance to real life.
Like, I'm more in my coursework so far, I haven't been like solving real life problems. I've more just been learning how the world works. I'm like, oh, that's neat. Like, I'm in my electrical and optical properties course right now, and I'm actually learning what things being transparent means. It's surprisingly deep.
It's so simple, though. Whether either you see through or not.
It's electrons, the bandwidth, yeah. You start off freshman year taking Calculus 1, and then you're a junior and there's quantum mechanics, and you don't know what's going on, man. But we have another question from Leah.
This I know I can answer this because it's not a lot, because nuclear engineering is also a small program just like us, so the overlap is small. it is possible. We have had students who have did the dual major both in material science engineering and nuclear engineering. So that is a possible dual major. By the way, each student, excuse me, go ahead, Kotalı.
That might take maybe an extra semester.
It might not. Well, overlap, that's what I was going to say, actually. Because if you decide on a dual major, the earlier you decide, of course, the better. If you decide this in your junior year, we cannot help you. I mean, yes, then it will take longer. Absolutely. But if you are coming in, you already know, I'm going to do a dual major between this and this. You will get an advisor in both of those disciplines immediately if you declare both of them. Yeah. Then the job of the advisors is then to prepare a template for you, just for you, to make sure you can graduate in 4 years. Now, that might require you to take summer courses. Well, either at RPI or maybe where you live, right? There might be a college nearby where you live during the summers. You can take a course to transfer. So there will certainly be some effort required on your part, but we will do our best to make sure you can still fit everything within a 4 years, but that 4 years might include summers. Well, 1 or 2 summers. That's the caveat.